Mr. Barry here with you one more time, at least for this solving the quadratic equations using this method that we've been talking about in terms of factor by grouping. This is the word problem. I've just kind of shortcut the writing on the board. We do know there is a downhill golf shot, so there is a hill involved. We know h of t is the height of the ball, and that's going to be in feet. T is standing for time here in seconds. And the function that was provided to you is h of t is equal to negative 2t squared plus 5t plus 18. So we do have a negative here, which we kind of sort of assume because it's a parabola that's going downwards. We're shooting the ball down. So there is a little bit of lift on the ball, but then eventually, of course, the ball is going to hit the ground. So it is a negative a value here, which is going to come into play a little bit sooner rather than later. But first, the first thing it says was how high was the hill. So downhill shot, a shot that's happening from the hill. So let's go ahead and talk about that. And I would suggest to you that's where the ball is starting. So because this is written in standard form, we don't need to do any math work for this question. It's asking us about a y-intercept. Where is it starting? And we should know at this point that our answer is the constant if this quadratic is in standard form. So the height of the hill, we're going to go ahead and take this shot 18 feet off the ground. Of course, the hill being 18 feet tall. Off to the right side on your notes, there's a suggestion to factor the function. So it appears in intercept form. Of course, doing that would make it really simple for us to figure out the x-intercepts. X-intercepts help us figure out very quickly what the location of the ground is. So I'm going to take this function right here. I'm going to go through the pace of what needs to happen, and I'm just going to kind of pop it off over here in terms of factoring and getting it to intercept form. GCF-wise, negative 2t squared plus 5t plus 18. No GCF. Except for the fact that our a value is negative. We want to be able to control that a value being negative because of the fact we want the parabola to keep the same exact shape with the u going downwards. So 2, 5, 18? No. The t's? No. But let's make sure we have a negative 1 for a GCF. So we're going to call GCF here negative 1. That pretty much switches up the symbols here for all of us. All of our terms in this quadratic trinomial. The 2 becomes positive, 5 becomes negative, the 18 becomes negative. And because I wanted to get this in the intercept form and focus on x-intercepts when this thing hits the ground, I'm going to go ahead and just say that the height would be 0, because if it's on the ground level, it would be at 0. Let's take a look inside. That's still a quadratic trinomial. That's not intercept form. So based on that, let's figure out a, b, and c. A value inside the parentheses is 2. B value is negative 5. C value is negative 18. We need those factors of AC that would add up to B. So here AC 2 times negative 18 is negative 36. The B value here for us is negative 5. We need two numbers that would multiply to AC and add to B. Now this process you could certainly do in your head. Some people might find it a little bit easier in this situation because 36 has a bunch of them to write out. Not worrying about the negatives right this second. All the different ways to get to 36 using multiplication. Not worrying about subtraction or addition at this point. Take a look. 4 and 9. Alright. So we need 5. If I do 4 times 9, that's positive 36. We need a negative. If we do negative 4 times negative 9, we get a positive 36 also. So one of those two numbers there for 4 and 9 have to be negative. One of them has to be positive. When we add it together, it's got to be a negative 5. So I'm going to make the 9 negative. 4 times negative 9 is negative 36. 4 plus negative 9 is -5. Alright, so keeping that GCF -1 out in the front. 4t minus 9t, not changing anything mathematical value-wise, because it's still -5t, but changing the appearance. So now we'll get into grouping, or factor by grouping. Let's take a look at this binomial in the front. 2t squared plus 4t. 2 and t, all part of the GCF here for that binomial. And we'd be left over with a t plus 2. I'm anticipating that common binomial. I'm hoping to see a t plus 2 again in the parentheses. Now I have -9t minus 18. Both are negative, especially the leading coefficient, a little bit more important. But the leading coefficient here, the 9, is negative. So both divisible by -9, not t. And if I pull out a -9 from those two, that binomial, it would leave me, in fact, with a t plus 2. Finish up the factor by grouping. We'll get our groups together. I got my common binomial, t plus 2. And I have my binomial that's formed by the GCFs, 2t minus 9. T is equal to -2. T is equal to 4.5. Of course, that's coming from the fraction 9 over 2. So I've gotten my quadratic not only from, I guess over here, standard form all the way to intercept form. I actually went ahead and solved it. So we know there are x-intercepts here. We have a couple questions to answer. How long is the ball in the air? Technically, our x-intercepts are -2 and 4.5, but we know that there's no such thing as negative time. So if I had this on a graph, we would be starting right here at 0, 18, hitting the ball, and where we hit right here would be 4.5, 0. So even though -2 is a solution for us, it is an x-intercept here. We're not really focused on it in this word problem because we know there's no negative time. The amount of time this path has taken for the ball to be in the air would be from 0 seconds to 4.5 seconds. So, ball in the air, 4.5 seconds. When does the ball hit its maximum height? That we would need to use our x-intercepts. And even though it's not in play over here, we know technically we would have an extension of this parabola hitting over here at -2, 0. Now that's not really part of our situation here, but we do have to take it into consideration in terms of finding our axis symmetry. We need to take it into consideration figuring out when does the ball hit the max height. So I'm going to go ahead and write down when max height. 2 x-intercepts. We'll add them together and divide by 2. 2.5 divided by 2 would be 1.25 seconds. So 1.25 seconds is when this ball hits its max height. Of course, we can go ahead and figure out the actual max height by plugging that in. You can plug that into a bunch of locations. You could plug it in over here, up here. I kind of sort of like the beginning because it's in standard form and this has a lot of parentheses going on, which we love for the x-intercepts. But for plugging a number in physically into the function, I'm going to go back to the original. Again, I could do that everywhere, but the actual max height, not the time frame for it, is what we're trying to figure out. Again, I'm going to use the original function and plug in my axis symmetry. And 1.25. So I have this standard form. I plugged in 1.25. I wish it could be really cool and off the top of my head go ahead and tell you what the answer is, but unfortunately I don't think that would be the case, so I am cheating and using a calculator here. And I almost have it typed in. Now obviously we have to be above the number 18 because that's where we started from and it wasn't the max height. I got 21.125. 21.125. That is the max height off of this ground level right here that our ball hits. So 1.25, 21. 1.25 would be our max height. So a word problem that has a lot involved with it. It is all based off of knowing that x-intercept. Last unit, we weren't able to do this easily unless we kind of fell into a step pattern. The y-intercept here was pretty easy for us. Not a lot of thinking on that one, but after that, all of these things right here reside on the fact that I know how to factor. I know how to get this to x-intercept and find the x-intercepts. Once I have that, I can talk to you about how long the ball's been in the air, what the max height was, when did it actually happen.